By now we already know how to use Docker. We can run containers, we can connect networks, we can attach volumes, but the problem is there are a lot of commands and even more flags. Docker run, network, volume, amp, and that's just the beginning. Now imagine this, all of that in one file and only one command. This is exactly what Docker Compose is about. On the left, classic Docker, multiple Docker run commands, hard to read, hard to remember. On the right, Docker Compose. One command we need, Docker Compose up. This is the reason Compose exists. So what Docker Compose is? Docker Compose is a tool. It allows you to describe multiple containers and how they work together. You describe which containers you need, how they are connected, which ports and volumes they use, and all of this lives inside a single file, docker-compose.yml. Docker Compose is used everywhere. Local development, pet projects, demos, CI/CD environments. Compose is a daily tool for a huge number of developers. However, it's important to clarify that Compose is not Kubernetes. It's not a production orchestrator for huge clusters. But for pet projects, demos, local development, it's absolutely amazing tool. In this video, we will build a very simple stack reusing code from previous video. A browser talks to a frontend, the frontend talks to a backend, multiple containers, one compose file, one command to run everything. Simple but very realistic. Let's start from scratch and write our first Docker Compose file. Even if you never used Compose before, the file should be readable. The most important section in Docker Compose is services. Each service is just a container, nothing more. And the service name is very important. It becomes the DNS inside the Docker network. Inside the service, we describe the image or build context, ports, environment variables, and dependencies. So service is not an abstraction, it's just a regular Docker container described in a nicer way. We made a backend, now let's switch to the frontend. We are using not default Docker file name, so here we should specify that. Also, we know that frontend is our entry point to the application, so we need to specify two ports. The external port 8080 of our machine and the port 80 of frontend container. Also, we add depends on, which controls startup order. Ports are often confusing, so let's clarify this. We use ports only when we want to access a container from the host machine. Between containers, ports do not need to be published. And now the fun part. When Docker Compose is ready, we can use docker compose up command. Compose builds the images, creates a network, and starts all containers. We just launched multiple containers with a single command. To understand the funny part, let's compare two different flows. Thanks to the Compose, we need only one command. Now let's make sure that everything works. Everything works fine. Docker Compose treats the whole stack as a single unit. We can start it, stop it, and view logs from all services at once. Now let's make a little upgrade and use more capabilities of Docker Compose by adding database. Firstly, we need to change a little our Flask app. Now in the app, we connect to the Postgres and return the first message from messages table. And also we add our new dependency to requirements file. Now we can change our Docker Compose file. First, we need to pass environment variables, which we use in Flask application. Now we can define our new service. We will call it DB. We don't need to have any Docker files, so we can use image from Docker registry. So here we define what image we will pull. We also need some environment variables here, so let's define it. As long as we want to have persistent database, we need to define volume. Here we describe where DB files will live. Also, don't forget about the volume in the end of the file. Now let's start our application again. As you remember, in our Flask application, we go to Postgres, we check table messages and get the first message. Now we need to actually create the table and insert some message. The fastest way to do it is to use PSQL. Here we are logging to database with user demo, with password demo, and with two simple commands we are creating the table and insert the message. Let's check that everything works. And we got hello from Postgres now. In the next video we will talk about image optimization and best practices of Docker. Hope you enjoy, see you soon.